Welcome, Algebra 1 students, to this fabulous edition of Comet Algebra. We are going to be looking at section 12.3, Completing the Square. It would be helpful for you if you had your book open to page 495 so I can refer to a diagram on that page, and we're going to discuss this a little more in class, but for the purposes of the video, it's nice to be able to look at page 495. So in this chapter, we've learned two ways to solve quadratics. We solve them by factoring, and then we solve them by taking the square root of both sides. Well, in completing the square, we're going to combine those two skills and learn a new piece about what it means to complete the square. So some quadratics, like x squared plus 6x plus 2, cannot be factored. We can't isolate the x squared and then take the square root of both sides. So we need some more different ways to work with these quadratics. Completing the square is a method where we figure out what we need to add to both sides of this equation to build a perfect trinomial square over here on this side. Because if we build a trinomial square, we will be able to factor it. And if we can factor it on the one side, then we'll be able to use the strategy of taking the square root of both sides. So this is combining a lot of different things. So first, let me just remind you, how do you factor a perfect trinomial square? Well, first of all, let's review what is a perfect trinomial square. This is a perfect square, the first term. The last term is a perfect square. And then this middle term has to be, when you FOIL it, the outer product plus the inner product. So you always need to check that. So the way we factor these, square root of x squared is x. So setting up my parentheses. And the square root of 9 is 3. And since this 9 is positive, and this middle term is positive, these are both positive. And just doing a quick check, the inner product is 3x, the outer product is 3x, and that does indeed add to 6x. So this is certainly a perfect trinomial square. And recall, we don't have to write these both. We can write this as x plus 3 quantity squared, and that's what we're going to do in completing the square when we're solving it, is write it this way. So now I'd like you to consider the question, can we take that original equation we started with, x squared plus 6x plus 2 equals 0, and is there something that we could add to both sides to make the perfect trinomial square on this side of the equation? Well, if we refer back up here to my example, if this plus 2 were a plus 9, then it would be a perfect trinomial square. So if I would write this as x squared plus 6x plus 2, and then I'm going to leave a blank here for myself, and then I'll keep the 0, and I'm just setting these blanks up to remind myself that whatever I add to this side, I must add to this side. Now, knowing that if we have a 9 right here, it is a perfect trinomial square, do you agree that if I have 2, I only need to add a 7 here? And then 2 plus 7 would give me that 9. And if I added a 7 on this side, I would need to add a 7 on that side. And so let's see what we've done here. Simply by adding a 7, we have taken this x squared plus 6x plus 2 and turned it into x squared plus 6x plus 9 equals 7. Now it doesn't equal 0 anymore, but that's okay, because what I have done now is I have given myself this trinomial square which can be factored. So I factored it into what we knew, x plus 3 quantity squared, and this equals 7. So now we go back to that skill we learned of taking the square root of both sides. And we do that. We take the square root here and the square root here. And again, this squared cancels that square root. So I have x plus 3 equals plus minus square root 7. And remember, we have to split this up to get our two answers. And then if I subtract a 3 from both sides, subtract a 3 here and here, my two answers would be square root 7 minus 3 and negative square root 7 minus 3. So I've done all the steps here and kind of thrown it at you all at once. So let's break it down now and go through this process. All right, here's where the notes part come in. So if you need to pause the video to write this down, please do so. This is the list method that we typically write down because it's nice to have the steps to follow and eventually you will remember them. So to define completing the square, it is the process where we add a number to both sides of the equation to build a perfect trinomial square on the left side. The steps to do this are, first, write the equation in the form x squared plus whatever b is, whatever number is in front of your x, equals, and then put the constant on the right side. And then to complete the square, we grab the number that's in front of the x, in this case I'm calling it the b, we divide it by 2, we square that, and we add that to both sides of the equation. Then we follow the steps that we did above. We factor that perfect trinomial square on the left side. We take the square root of both sides, and then we solve the equation. So you may ask, it would be a great question, why do you divide by 2? And that's why I wanted you to have your book open to page 495. If we were to represent this quadratic with shapes, with squares and rectangles, that's what they're doing on 495. That blue square represents the x squared in our equation, and the green rectangles represent that we had 3 x's, well we had 6 x's altogether. But in order to build those shapes into a square, we had to split those 6 x's in half, and you can see they lined up 3 of them on the right side of the blue square and 3 of them below the blue square, and that left a void in that corner that we have to fill up with 1s, with the little red squares. And so the question is, how many little 1s are needed to finish making that into the shape of a square? And the answer is we need 3 across the top, 3 down the side, so we need a 3 by 3, so that's 9. And that's why we cut the number in front of the x in half, because we're putting half the x's alongside and half below, and then we're filling in the 1s. And like I said, I will demonstrate this for you in class to make that a little more clear. So let's look at some examples next. In these first 3 examples, we're not going to be finishing the process. We're just going to learn that first step. It says, what number must be added to complete the square? So we have x squared minus 16x, and we need to add something right here in order to make this a perfect trinomial square. So if we follow the steps that we just wrote down, we're supposed to take this number, this negative 16, it's sitting in front of the x. Take the negative 16, divide it by 2. Negative 16 divided by 2 is negative 8, and then we're supposed to square that. Negative 8 squared is 64. So if I added a 64 right here, I have just built a perfect trinomial square. I have completed the square. And if you picture that, it's like having 16 of those little green rectangles. We split them in half. We put 8 along along the top and 8 along the side, and then we needed to fill in that 8 by 8 gap, and that would take 64 of the little tiny squares. So we completed the square. Now factoring it, this is just a review of the factoring part. Square root of x squared is x. Square root of 64 is 8. And this is negative, the 16 is negative, so both of these have to be negative. And of course, the more efficient way to write this is x minus 8 quantity squared. Next example. This time, the number in front of the x is not an even number, so it's not going to divide by 2 quite as nicely. But we still need to follow the steps to complete the square. We need to figure out what we need to add to this to build a trinomial square. So the math is the same. We take the 1 that is sitting in front of the x and we divide it in half. So half of 1 is 1/2. And then if you square 1/2, you get 1/4. So we would need to add a 1/4 here. And this looks a little weird, but we factor it exactly the same way. Set up your parentheses. Square root of x squared is x. Square root of 1/4, these are both perfect squares. 1 is a perfect square, and so is 4. So the square root of 1/4 is 1/2. These are both positive, so these have to be positives. And of course, the more efficient way to write this is x plus 1/2 quantity squared. Now you may want to just check for your own curiosity. Do we end up with a 1x here if I FOIL? Well, the inner product is 1/2 x. The outer product is also 1/2 x. And 1/2 plus 1/2 is a whole. So this does indeed FOIL out to be the original trinomial. And sometimes, like in this next example, our letter B is already a fraction. But the process remains the same. So let's do the math. We have to figure out what we need to add right here to build a trinomial square. Well, if we had 3/5 and I want to take half of that, divide it by 2, remember we don't really divide fractions, we multiply by the reciprocal. So dividing by 2 is the same as multiplying by a half. So half of 3/5 is 3/10. And now that I've divided it by 2, I need to square it. 3 squared is 9. 10 squared is 100. So this is what I need to add here to complete this trinomial square. And again, you'll notice because we squared this fraction, the one that we're adding is going to be a perfect square, so it factors very nicely. Square root of x squared is x. The square root of 9 over 100 is 3/10. And I'm just going to write that as quantity squared. So now we've learned this first step of how do we complete the square. And we need to put these skills together now and take it from start to finish, from completing the square to solving the equation. All right, I noticed that my first example is already written with the x squared and the x term on the left side. I'm going to draw a line here, a blank, to remind me that's where I'm going to be adding something to complete the square. I'm going to leave the 9 on this side and add a line to remind myself that I have to add something to both sides. So following the math, take the 8, divide it by 2 is 4. 4 squared is 16. So I need to add a 16 to both sides. After you have completed the trinomial square, then you can factor this side. And it factors very nicely into x plus 4, x plus 4. So I'm going to write that as x plus 4 quantity squared. And then I go ahead and add 9 and 16, and I get 25. So now we use the skill that we learned, where if we have the if this is isolated and we're squaring it, we take the square root of both sides. Again, this square root cancels out that squared, and I'm left with x plus 4. Square root of 25, remember, is two answers, plus minus 5. Here's where I write out my two equations. In the first equation, I'm going to use this plus sign. In the second equation, I'm going to use the minus sign. So I have x plus 4 equals 5, and x plus 4 equals negative 5. Subtract a 4 from both sides. My first answer is 1. Subtract a 4 both sides here. My second answer is negative 9. So we have solved this quadratic. We have found the two answers by completing the square. In this second example, I see that it's not written with the x squared and the x on the left side, so I'm going to do that. Again, I'm going to leave a blank. And then I'm going to move this negative 14 over to the other side by adding a 14. And again, I draw a blank to remind me that I'm going to be adding to both sides of the equation. So taking this negative 5, half of it is negative 5 halves. Squaring that gives me 25 fourths. So I need to add 25 fourths to this side and 25 fourths to that side. Once again, this is a perfect trinomial square, so I factor it. Since this is a negative sign, this has to be negative. And the square root of 25 fourths is 5 halves. And then over here, we need to do some common denominators to add our fractions. So if I change 14 into fourths, I get 56 over 4, and then I need to add to that 25 over 4. And if I add those together, I get 81 fourths. So let me just rewrite that here so we can see it clearly. And once again, I'm at the point where I need to take the square root of both sides, square root this side, square root this side. So I have x minus 5 halves equals, and this turned out to be a perfect square, which is very nice, plus minus 9 halves. So once again, I have to write this both ways with the plus and the minus sign. So then if I add a 5 halves to both sides, here I would get x equals 14 halves, which is 7. Here, if I added a 5 halves to both sides, I get x is a negative 4 halves, which is a negative 2. And there are my two answers for the quadratic. All right, we have one more example to do where, again, the b is not a whole number, it's a fraction, but we follow the same exact steps. So we take the 3 halves, the 3/5, and take half of it. We get 3/10. We square that to get 9/100. And this is what we add to both sides. So I have x squared minus 3/5 x plus 9 over 100. And then I add the 0 and the 9 over 100 on this side. Once again, factoring this, square root of x squared is x. This is a minus sign, therefore I need a minus sign here. Square root of 9/100 is 3/10. It would be quantity squared because there would be two of them. Then we take the square root of both sides. X minus 3/10 equals plus minus 3/10. So writing the plus minus here, then add a 3/10 to both sides. So this first equation would give me x equals 6/10, which reduces down to 3/5. There's one answer. And adding a 3/10 to both sides here gives me x equals 0. So these are my two answers for that quadratic. All right, have fun with completing the square.